Hi, everybody. It is time for us to start looking at everybody's favorite chapter, the transformations chapter. So we're going to start here with lesson 3-1, which is reflections. Number 11, Becky draws a triangle with these vertices on a coordinate grid. She reflects the triangle across the line y equals 4 to get a triangle A prime, B prime, C prime. She then reflects that image, that picture, across the line x equals 3 to get A double prime, B double prime, C double prime. What are the coordinates of A prime, B prime, C prime, and the double primes? So first we've got to find out what the coordinates of A prime, B prime, C prime are. So if we are reflecting across the line y equals 4, that means that what we'll need to do is change the y coordinates of these original points. And we're going to change them by saying, how big is the difference between the y coordinate and the reflection line? So here, 7 is 3 units above 4. We're going to copy that distance below the reflection line. So 7 is 3 units above 4. Then we go 3 units down below the line of 4, and we get to 1. So my new coordinate point is going to be, well, I guess I should put all of these separately now that I think about how to write this. We'll do A, then B, then C. So A prime is going to be still 6 there. But instead of 7, we drop down to 4, and then we drop down 3 more to 1. B prime, again, we look at the y coordinate, it's 3. 3 is 1 unit below 4. So my reflected point is going to be 1 unit above 4. So it's going to be 5. So it's going to be 9, 5. And then C prime is going to be, let's see, -2 is our y coordinate. -2 is 6 units below a +4. So we're going to go 6 units above a +4 to get 10. So that point is going to be 4, 10. Then to get the double primes, we're going to do the same thing, except this time we're using the line x equals 3. So we're going to change the x coordinate in the same way. So we're going to take the A prime coordinate. The x coordinate is 6. That's 3 units above 3. So then our new point is going to be 3 numbers below 3, and that's going to be 0. So it's going to be 0, comma, our y won't change, so that's 1. B double prime, our x value 9 is 6 units above the reflection line 3. We're going to make it 6 units below the reflection line 3, make that -3. The y value is still going to be 5. And then C prime, it's at 4. 4 is 1 unit above 3. We're going to make it 1 unit below 3, or 2, 10. Then it says write a rule for each reflection. There are lots of ways to write reflection rules, but we do it pretty simply. For the first one, we're going to make a capital R, and then subscript, we have to write what's the line of reflection. Our first line of reflection was y equals 4. So it's a reflection across y equals 4 of triangle ABC. So we're going to write what we're reflecting, triangle ABC. Our next reflection is also going to be a reflection. This time it's across the line x equals 3. And this time we are reflecting triangle A prime, B prime, C prime. So we're reflecting that image, triangle A prime, B prime, C prime. And that's going to be the rule for our reflection. Number 12, under a transformation, a pre-image and its image are both squares with side lengths 3. The image, however, is rotated with respect to the pre-image. Is the transformation a rigid motion? Well, a rigid motion is any movement that is going to have the same, or give an image with the same side length and angle measures. Well, the image and its pre-image are both squares with side length 3. So they're both having the same side lengths, and they're both the same shape, right? The same angles. So that means that it is a rigid motion. So yes, we can say rotations, which this is, will still give the same side length and angle measures. Rotations will still give the same side length, and angle measures. All right. Number 13, Jacob is playing miniature golf. Oh, where is this? This picture is down here, sorry. He states that he cannot hit the ball from the start, bounce it off the back wall once, and reach the hole in one shot. Is he correct? We can probably make this happen. Let's see. So he wants to hit the ball once, bounce it off the back wall, and make the shot. So if we start at the hole and we say, well, right now we are this far away, however far this far away is from the back wall, we can make a reflection. We can say, what if I were to reflect the back wall over the line of reflection and make it the same distance above the line of reflection as that hole is below the line of reflection? Then I can go in here and I can find a shot that's going to connect the ball here, or the reflected point of the ball, and the ball at the beginning. And what I find is that this point right here, where my first shot is going to hit that reflected point, that is where I should aim at. And if this person aims at that spot, then the ball is going to bounce off the spot and go directly into the hole. So as far as error analysis goes, Jacob was incorrect. Number 16, can a figure be reflected across 3 lines of reflection so the image is the original figure, and explain? So yes, it can. There are lots of ideas for making this happen, but one way we could do this is just to draw. So maybe we'll use a triangle, and we'll say, all right, we'll start here. Whoa, I didn't know we could do that. Triangle. Okay. And I'm going to make it symmetrical. I'm going to make it an isosceles triangle. And I say, well, if I take this and I reflect it across a line of reflection here, that'll be my line of reflection. And I'm going to get the same triangle. I'm going to try out some new tools here. So I'm going to get the same triangle and copy that, paste that, but it's going to be on this side of the reflection line. Okay? So this is reflection number 1. So I'll call this triangle number 1. I'll call this triangle number 2. And then I'm going to reflect it across another line of reflection. So now I'm going to reflect it across another line of reflection over here. And when I reflect it across another line of reflection, this triangle that is number 2 is going to be reflected over here. It's going to be the same distance away from the reflection line. And I needed to say 3, not 2. I didn't even think about that. Yeah, all right. So this is going to be number 3. So I reflected it across 2 lines of reflection so far. Then my next move is going to be to take triangle number 3, reflect it back across the center of that line of reflection. And when I do that, I'll show you with arrows the path this is going to take. So we'll go from triangle 1 to triangle 2. And then we'll do another reflection to go from triangle 2 to triangle 3. Then when I reflect backwards across the blue dotted line, triangle 3 is going to map itself back onto triangle number 1. And that means that this figure then is reflected across 3 lines of reflection, so the image is the original figure. It goes bloop, 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 back to there. There are lots of other ways that could work as well, but drawing a diagram is a good idea. Down here, we've got a lot of different options going on, so we're going to need to read the question carefully. Suppose M is the line with the equation x equals -5. Suppose N is the line with the equation y equals 1. Line G is the line with the equation y equals x, and line H is the line with equation y equals -2. Given points A, B, and C, what are the coordinates of the vertices of triangle A prime, B prime, C prime for each reflection? The first one is going to be a reflection over the x-axis. So we've got to find A prime, B prime, and C prime over a reflection over the x-axis. Of course, the x-axis is the line y equals 0. That's kind of confusing, but remember that, right? Y equals 0 is a horizontal line on the x-axis. So if we are reflecting a point across the x-axis, what's going to happen is our x-coordinate is going to stay the same, but our y-coordinate is going to get flipped. So instead of -3, this one will be +3, because instead of being below the x-axis, it's now going to be that many above the x-axis. So we can write that A prime is going to be 9, +3. Same thing with B prime and C prime. B is going to be 6, -4. Again, we're switching that sign. And C prime is going to be -1, +5. For number 20, we're reflecting it over the y-axis, which, if you remember, that's the vertical line x equals 0. So we are going to be changing the x-coordinate here. So for A prime, B prime, and C prime, we're still basing them off of the original coordinate points in the problem, these ones up here. And so when we say, all right, I have my original point is at 9, -3, my new point is going to be the x-coordinate switched. It's going to be -9, and the y-coordinate is still going to be -3. It'll be -9, -3. Same thing with B and C. B will be -6, 4. C will be +1, -5. All right. 21 and 22, they say a reflection over line M and a reflection over line N. Let's see, reading through here, suppose M is the line with the equation x equals -5. So that's our first one. We're reflecting over x equals -5. So we're going to look at how far away our x coordinates are from -5. And we're going to flip them so that they are that far away on the other side of -5. So for my A prime, for example, my original A coordinate is 9. 9 is 14 units above -5. So to get the A prime coordinate, we're going to go 14 units below -5. -5 minus 14 is -19. So A prime is -19, -3. B prime, same thing. B is at 6. 6 is 11 units above -5. So we're going to go 11 units below -5. -5 minus 11 is going to be -16, 4. And C prime is, well, C is at -1. -1 is 4 units above -5. We're going to go 4 units below -5. -5 minus 4 is -9. And our y-coordinate is just -5 there. And then finally, Rn, a reflection over line N. Line N is the line with the equation y equals 1. So we'll go over here. We'll do our A prime, B prime, C prime, all based on how far from y this is. Okay? So we'll look at how far from y each of our y-coordinates is at. Our x-coordinates will stay the same. So for A prime, that 9 will be the same as it was. But -3 is 4 units below +1. So our new number is going to be 4 units above +1. That'll be 5. Then B prime is going to be 6, 4 is 3 units above 1. So our new number is going to be 3 units below 1, or -2. And for C prime, we have -1, -5 is 6 units below 1. So our new number is going to be 6 units above 1. So that'll be 7. And that's our answer. Down here, what is a reflection rule that maps each triangle and its image? What I'm looking for here are changes between the original point and the new point. I see that the y-coordinates stay the same. So our reflection must be over an x equals a vertical line. Just the x-coordinates are changing. So my x-coordinate goes from 3 to 1, from -4 to 8, from 6 to -2. I am looking for the number that is exactly in between those numbers, right? It'll be a number that's exactly halfway between all of those numbers. So the number halfway in between 3 and 1 is +2. And if I check the other numbers, +2 happens to be halfway between -4 and 8, happens to be halfway between 6 and -2. So my line of reflection is x equals +2. So I'll write it is a reflection over the line x equals 2 of triangle DEF. Right? Same thing for 26. We look for differences. Our x's stay the same here, but our y's change. So we're going to look for the number exactly in between, right? Because one of these is a reflection above the line, and one of these numbers is a reflection below the line. So if I look at 8 and 2 and I say, well, what number is exactly halfway in between 8 and 2? That number is 5, and it changed the y coordinate. So it's a reflection over the line y equals 5 of triangle GHJ. There we go. Number 29, trace the diagram below. We don't need to do that because we're on a paper. Where does the shopper in a dressing room see her image in each mirror? Pretty simple, right? We've got the shopper going to mirror 3. We'll just do these backwards. And I'm going to make this perpendicular and the same distance away, right? And that's where she sees herself. It's going to be the same distance between the shopper and the mirror and mirror 3. It's also going to be perpendicular. That's how our reflections work. So between the shopper and mirror 2, same thing. It's going to be perpendicular this way. And we'll eyeball the same distance. And we'll say, here's her. It's going to be the same distance. We'll use 2 hash marks here. And it's going to be perpendicular. And then for the shopper and mirror 1, we're going to have to extend the line of the mirror. Because if we draw a line perpendicular to where that mirror is, it's going to go off this page. Look at this. It's going to become, not off the page, but off where the mirror is. Take a look at this point right here. She's seeing her image in mirror 1, but she has to extend the line of reflection to see where she would theoretically see her image if she looked in mirror 1. Okay, that reflection line can be extended in both directions from where it looks like it is now in order to create that perpendicular bisector that we need to show a reflection. Number 30, which of the numbered stones shown cannot be mapped to another with a rigid motion? So we're being asked which of these stones does not have a buddy, right? So if we look at these and we try and find pairs, I see that number 1 and number 9 are the same. So those are out. Number 2 and number 4 are the same. So those are out. Number 3 and number 6 are the same. Number 5 and number 10 are the same. And then 6 we already got. 7 doesn't have the same shape buddy. So 7 is one that we need to write down on here. 8 also doesn't have a buddy of the same shape, so 8 goes down there. 9 we covered, 10 we covered, but 11, 12, 13, and 14 are all unique shapes as well. So 11, 12, 13, and 14 go on here as well. That's all this question is asking us. 32, it's like down here, and we are also using these 2 questions up here, so I'll be moving back and forth for 32. Look at the floor plan below. Abdul sees the image of a clock in the mirror on the door. Trace the diagram. Where is the line of reflection? So if the mirror is on the door, then the line of reflection is the door, okay? He can extend the line of reflection if he needs to, because we can see things on both sides of a mirror if we need to, right? We don't just look in a mirror and see things that are right in front of the mirror. we can kind of see things that are on opposite sides of the mirror. So our line of reflection is the door because the mirror is on the door. We'll call this line L. So where is the line of reflection? It is line L because the mirror is on the door. Okay? Next, the question is, where is the clock located? So let's go back down here. This is the image of the clock. Remember, pre-image and image. Image means that this is not where the clock actually is. The clock is actually across the line of reflection. This is the reflected image of the clock. So we have to see where the clock started out to make it come over here across the line of reflection. So I'll use a different color here, and we'll say, well, we'll make it perpendicular to the line of reflection so we can figure it out. I think that's the perpendicular. And if we take a look, here and here are going to be bisected, and we've got perpendicular here. So the actual clock is on the wall. This is where the clock really is. But when Abdul looks into the mirror, he sees the reflection of this clock. And when he sees the reflection of this clock, he sees it out in his field of view as if it were out here. We know the clock's not out here, right? Abdul knows the clock's not in the middle of the room. But when he sees it through the mirror, it looks like he's looking straight at it, when it's really down here. So when we come up here, we answer the question. Say the clock is located on the wall. So it's on the wall. It's reflected over the door's line of reflection. It's reflected over the door line of reflection. And finally, find where Abdul's image is located, right? Where is his reflection located relative to the line of reflection? Can Abdul see himself in the mirror and explain? So in order to find where Abdul is related to the line of reflection, we're going to draw a line from Abdul to the line of reflection, and we're going to make it perpendicular and go about the same distance on the opposite side as we are from the mirror. So now we have this bisector and it's perpendicular. The question says, can Abdul see himself in the mirror? So what we need to think about is, if he looks in the mirror, let me get my pointer here. If he looks in the mirror, is he going to be able to see himself? He unfortunately is not, because where there was a clear line of sight, he'd be looking through the mirror at himself before. Here, there's a wall in the way, right? If he was trying to look for where he was by looking in the mirror, he couldn't find himself because there's this wall right here that's going to block his view of himself. All right? And I know that's a tricky concept, but if you think about where he is, the things he sees in the mirror are going to be things over here. They're not going to be things over here because that's not the angle at which he's looking at the mirror. So he's not going to be able to see himself in the mirror, even if we extend that line of reflection, because there's walls in the way. So we'll write that up here. Can Abdul see himself in the mirror? Blah, blah, blah. And we will say no, because if he's reflected over the line of reflection, no, because if he is reflected over the line of reflection, then he can't see his reflection by looking in the mirror. He can't see his reflection by looking in the mirror. All right. 33, classify whether each pair of figures appears to be a rigid motion or not a rigid motion. So are the pre-image and the image the same or not the same? Easy as that. These two seem like they would be a rigid motion because the pre-image and the image appear the same. In the next one, the pre-image and the image appear the same but rotated, so that's a rigid motion. This pre-image and image down here seem to be different sizes, so that's not a rigid motion. And in the last one, the pre-image and the image seem to have different angle measures, so that's also not a rigid motion. And 34, considering the following reflection, we've got our pre-image points and our image points, and I immediately notice that my x coordinates are changing while my y coordinates are staying the same. Suppose P is the line of reflection x equals 11, Q is the line of reflection x equals 22, R is the line x equals negative 11, and S is the line x equals negative 22. Which of those is the rule for the reflection? So we're looking for the number exactly halfway in between these x coordinates, right? So exactly halfway in between 3 and negative 25. If the numbers are far apart, remember you can find the average. That's exactly halfway. So we can do 3 plus negative 25 over 2, right? So we can say that's going to be negative 22 over 2, which gives us negative 11. So negative 11 is halfway in between those coordinates, and that is line R, which is that equation. So we'll use choice C, a reflection over R of x comma y. And that is everything for this worksheet. Please let me know if you have any questions, and have a wonderful day.